Okay, so the next part is part 4, strings and regular expressions. A string, for those of you who don't know what one is really just a collection of characters. So a sentence can be a string, a word can be a string, 1, 2, 3, 4, 5 can be a string if we want it to be. And of course what we can do with strings is we can filter them, and we filter them using regular expressions. In other words, we can look for occurrences of a particular letter, we can filter out numbers, we can filter out spaces, we can filter out underscores, we can turn uppercase to lowercase. We can really do a lot of exciting things with regular expressions. Hand you over to Mike, who's going to take you through the example now.
Okay, so we can pop up our idle console again, and this was a continuation on the previous video. So if we have a look at the examples it's asking to do, so the first thing it's doing is it's creating a string called mySent. So mySent, and we're saying is going to equal to, we're going to open it with quotes.
So mySent is now just going to be a string, right? That's what we're doing here.
The cat sat on the...
You will have seen this obviously in your Python last year, and see if you've ever done it and so on.
I've closed it with a quote as well. Okay, so now we have a string. So if just to give an example, I can print that.
Print mySent, we should see that, yeah.
Like so, and let the cat.
Lo and behold, there's your string. Yeah, that's great.
Okay, so let's look at tokenizing this in a way. So we're going to use the word tokenize function that's found within NLTK. So I need to import that function. So I'm going to say from NLTK import, and the function I want to import is word tokenize. Word underscore tokenize, spelt with the American spelling. Yep. So I import that, no errors, everything's written okay. So I'm going to create a variable called mySent underscore tokens, so I can store my tokens in this. So I'm not going to use capitals there. Tokens.
Shouting, isn't it?
It's shouting, yes. And I want that to be filled up by the word tokenize function. And as the parameter for the word tokenize function, I'm going to send my variable that I created, the cat sat on the mat. So if I press enter on there, I get a lovely command, no errors. Now I need to look at the contents of mySent tokens. So I want to see now what's inside my variable, mySent tokens. We have a look, and it's tokenized that string. It's tokenized the cat sat on the mat and the full stop at the end.
So let's be clear about this. So what it's done on this particular one, to me it just seems like it's separated words out because of the spaces in between them. Is that right?
Yeah, that's from this point of view now, as it stands, that's the default working of word tokenize,
so
because the word bit.
The 0th element, cat is the first element, sat is the second element.
Yep.
And we can index those, right?
We can, and let's have a look at the length. mySent tokens, and it's saying the length is
so
set.
that means we could set up a for loop, and we could say for blah blah in, or for length of mySent tokens, so we can actually use that to control any loop that we put around it.
We can, and as you can notice that it's not necessarily the space that the word tokenize function uses, because there's a full stop that's been also put as an individual token there, which wouldn't have a space typically between mat and the full stop. So sometimes we don't actually want to include a stop with a full stop or any kind of punctuation.
As a token.
Yeah. So to remove the punctuations, we can of course use regular expressions. And a regular expression allows us to match a string against a pattern. So if we want to check that our string sort of matches a start and end character, for example, a sentence start, a sentence end, or whether it starts with an A or D, as the lab script says, and end with a K, or can we find if a portion of the string matches some pattern? An example of this second case would be finding if a string X is a substring of Y. There are some string patterns which cannot be specified by regular expressions. We will not be going into details of them at the moment. So that was directly from the lab script. So let's have a look at that.
One example, that's where we learn, isn't it?
So a common way to do a regular expression is to use the RE library, which is a regular expression library that's given to us in Python. So again,
so
like all libraries,
we need to import
it. So it's part of NLTK, RE. So we from NLTK, yeah, that's what we're saying, and we want to import the regular expression part.
Yeah.
Oh,
So
yeah.
now we've got all the tools we need.
And to create a variable, we'll call that variable m, and we're going to use
We could have just imported the entire NLTK, couldn't
We
we?
could have, it would
But
certainly.
it would just fill the memory up a bit
would,
more if we
yeah.
could. Yeah.
So I want to search for lang within the sentence natural language processing. Okay.
Now clearly that's in there, isn't it?
They're clearly in there. So we're saying the first parameter is my search term,
Yeah.
and the second parameter is the text I want to search.
Yeah.
So if we hit enter there,
And obviously nothing's come up because we've just assigned it to the variable m.
exactly. So what do we need to do? We need to
Put
see
in
what's
M.
in M, don't we? So let's have a look at M, and we can say that we have REMatch object, which is the type.
Yeah.
It spans from 8 to
8 to
12, so
12.
this is the position that the search term has been found,
Yeah.
and the match is lang. That's rather interesting, isn't it? So let's look at this now. Right, we have M. M is now a special type of a variable. If we were to look at m.start, like so, it's telling us that start position is 8.
8, yeah.
If we were to look at m.end, it's telling us that the end position is 12. So what's happened there is the regular expression search term has created a class within this variable m, and that class has various functions that allow us to find the search term and further process the results from that regular expression search. So that's the first example. So we're going to close that video now, and then we're going to move on to some further regular expression examples. So if you want to have a go yourself, now would be a great time.